information-driven manufacturing process. I would like to take you to how the industrial evolution has taken place over the last 4 decades. If you look at 18th century, it was steam. And if you really look at UK has taken nearly 100 years to double their per capita income in 18th century. But India, this century, doubled within 22 years the GDP over there. Our GDP has grown 1 trillion to 2 trillion. And we have projected by the end of 12th plan to have $3.5 trillion as the GDP. And 19th century was electricity. And of course, the last century was oil and gas. Most of the industrial revolution has taken place on that. But on 20th century, what is it driving the industrial revolution? Is it hardwares? Certainly not. It's a big data. Why data is called big? Is there a data known as big or small? Certainly not. Data is a data. But why that is known as a big data? Because it's a conglomeration of many large set of data derived from machines or generated from machines directly, or by sharing the data between the machines in the process. So that's why that big data is coming in. And why is it so important? Because that is what drives the business in the coming years. Your capacity to analyze and utilize it into the processes, to take the competitive advantage, to make the products more competitive, to provide the after-sales service or the customer satisfaction within the shortest possible time. Which means the big data is going to play in 21st century, the industrial revolution. There's absolutely no doubt on that. And that's why that big data is known as the raw material, information raw material for the industry. If any taxation authorities will be present here, they will think how to tax that information raw material. Can we have an excise duty or a sales tax on that information raw material? I am sure at a later date something will come as a deemed taxation on this. But that information raw material, how does the manufacturer benefit? If you really look at enhanced competitive advantage, when you say how does the competitive advantage is coming in? Because the embedded sensors within the system can give you feedback, quite a large number of informations, especially on consumer goods. I was told there is one consumer good manufacturer in the United States making personal care products. They have 150,000 data coming every second, which if you translate into an hour, it is 545 million data. And in a year, it is 4 trillion data. So you can imagine the data which are coming in the coming from the information the machines used, how it is exploding into utilization of the customer service. Improve customer satisfaction. When you say improve customer satisfaction, because in the value chain, you can get all the embedded data directly fed to your sub-suppliers chains, whereby you can get products onto the market faster, better price level, and looking at the future, what maintenance actions you can take. So it's a question of conglomeration of various features built into. That's what that big data is giving in. Reduce downtime and enhance throughput. Naturally, when you do all these data coming in, your downtime is down, your proactive maintenance you can take care of. Cutting down the prevention, cutting down the maintenance time. And create tailor-made products for some subgroups. When you make analysis, you can find certain groups of people will doing certain amount of products with certain amount of features. That analysis can be put into use by servicing the niche market with least interference from others. And of course, increase innovation. It's a continuous process. Without innovation, you can certainly doubt. And also it helps in generation of the new products built into what the customer, what the market today needs. That's what the big data is coming. Certainly, it is nothing but the information raw material that will drive in the coming days. What are the challenges there? As I said, if you have a 4 trillion data over a period, how do you utilize the data? That is the biggest challenge. First is storage of the data. It's a huge challenge to have 4 trillion data for a company to have stored and analyzed it. And flexibility to leverage that data. You should have infrastructure. Apart from storage, how to retrieve it and how to reuse it. And again, the coming back is ability to. Today, the skill development, of course, in the previous session, that skill issue came up, especially on this. How to analyze on an online system and make it available to the user industry. And further is the technologies for further processing. That's the biggest challenge. So it's a very complex world which is coming in if you need to really look at how the data is fed into manufacturing. If these are the conditions which are coming, how do those technologies which are coming in? We have heard of internet for men. Have you heard of internet for machines? That is the challenge which is coming in. Machines which will have issues fed into the system, access directly to the machines on the cloud, solve the issues, correct itself, re-energize it. That is the vision of the future. Internet for machines. If not, in the coming 2-3 years, within 5 years or 10 years, you can see somewhere on the internet machines coming in. Wireless monitoring of performing assets. When I say wireless monitoring, there are of course wireless technologies in there. But if you look at the chemical process industry today, in a chemical complex, if you look at simple equipment of steam traps, I was told that steam is 1/3 of the energy in the chemical process industry which is consumed. But we seldom monitor the steam traps. If wireless system can be utilized to monitor steam traps in a process, the savings directly in terms of energy costs and indirectly in terms of protection of the environment is huge. 3D printing in industrial processes. In the United States, it has become much more common now. 3D printing. It is tomorrow you will see your newspaper will have a 3D television system to see. So that's what the technology is coming in. And additive manufacturing of complex shapes. Layers added on manufacturing. These are the new technologies which is coming into manufacturing, which will be data driven and which will give you the mileage over the competition or the others. Now, if this is the global scenario, how Indian scenario is, our industry's share in GDP today is less than 26%, and manufacturing is less than 15%. We have targeted by 2022, manufacturing has to go into 25% of the GDP. If that has to happen, the biggest challenge is 25% manufacturing in GDP by 2020, 10% or 11% year-on-year growth. It's the biggest challenge. Today, nearly 1 million engineering students come out of the colleges. And out of the 1 million directly employable is not more than 10% or 15%. Is it a problem related to the engineering students? No. It's a faculty. Faculty is not up to the mark. Or the facilities. So naturally you have a big challenge on, even if infrastructure is available, which is of course in the questionable level, we have a big challenge of the skill development. And of course, in which Automation Industry Association is taking a great strides in connecting the campus to bring up to the today's level of what industries needs, especially in control instrumentation side. Our country's present situation, if you look at, if you have to have 25% manufacturing, industrial infrastructure is still poor. Even if you are able to produce goods to the required level of the quality and quantity, to make it available to the remote area, it's a big challenge. Sometimes over-dimensional consignments delivery itself takes months together to reach. So how do you plan, especially in a world of EPCs? So infrastructure not really only roads and bridges, but all around infrastructure, including the skill areas, poorly skilled human resources. A lot of emphasis is being given. Now through National Skill Development Corporation, we have more than 23 skill development councils already there. And quite a lot of incentives are also being given government to develop. In the budget also I was told skill development is getting maximum attention. Weak supply chain. One simple agrarian country we have, we produce 400 million tons of perishable goods in the country. But only 15% is processed. The remaining is either wasted or locally utilized. Why? Because our logistics is not developed. We do not have an automated logistics system. We do not have road network suitable to them. So imagine 385 million tons of perishable goods is not able to be processed, not able to be leveraged on technologies. So weak supply chain is really creating a problem in a country like India where 47% of the people are employed in agriculture, whereas agriculture today contributes only 14% of the GDP. For a developing country, naturally it has to grow. In an agrarian revolution, when 47% of the working population need to have agriculture, naturally has to touch up to around 18 to 20%. Unless the technology comes in. Again, there is another study says 450 million smallholder farmers worldwide contributes 25% of the food output globally. 450 million. Whereas that 450 million, which is one smallholder farm, produces only 1.3 metric tons of maize per hectare in India or in the developing countries. If you look at the United States, it is 7 metric tons per hectare. So by utilizing the technology, by developing the capability, you can certainly develop this. Agrarian revolution can bring it. In India especially, with 80% is the smallholder farmers. Certainly our agricultural product can be brought. Agriculture can really bring up quite a large amount of revenue to the national exchequer to the country. Lack of affordable finance and high inflation over the last so many years inflation. If you look at infrastructure or if you look at industries, the growth engine is coming from micro, small and medium enterprises. Nearly 100 million people are employed in micro, small, medium enterprises. Today the cost of money to those industries, direct cost is 15%, indirect 17 to 18%. Is it possible to sustain with 17, 18%? No. So unless the cost of money comes down to the manufacturing industry, to the comparable level of base rate of 10%, 11%, no industrial development, no infrastructure, no skilling can be developed. Today, beyond the conventional system, micro, small and medium enterprises is not able to attract the intelligentsia from the engineering colleges because good available is going to the multinationals or large companies. So we need to certainly attract micro, small and medium to have that intelligentsia in order to grow. If growth engine is through micro, small, naturally the growth has to come from them is by having affordable finance on an average of around 10 to 11%. Poor integration of digitization, automation in our process. There should have been one slide prior to that which I left out because before integration I would say at least adoption of the automation itself in the processes. Today automation is not adopted to great level except for the continuous process industries, which is of course well managed, well matured. But if you go into other processes, automation is still very poorly adopted. So adoption of the automation is one process, and of course integration of the processes as well as the automation chain into the system is essentially required in order to get the mileage out of the present system of global competition prevailing. Now if you really look at what is it that integration of processes and automation is nothing but a digital factory we are talking of. Globally it is a prevalent now, it is predominant that a global system, digital factory system is operation in coming years. What is it, the digital factory system? When you integrate your processes. When you integrate your automation systems into integrated chain, it's nothing but becomes a digital factory. Your decision-making process cuts down. Your decision-making process gets through the intelligent connected devices you employed in. So product lifecycle management is one of the areas where you will look at. When you make a product lifecycle management, it's not likely the product life is. Even within the life, whatever upgradations you do, that's all can be captured to the benefit of the process and benefit of the throughput. Enterprise resource planning. To some great extent, it has been over the last 7, 8 years, it has been, a lot of focus has been, it has been employed to a great level in the, even in the medium, small, and today's world of cloud computing, SaaS, even small industries are able to accommodate or adopt the ERP systems into the system. Visualization and supply chain management. Which I said earlier, both are interrelated. If you are able to visualize things, if you are able to micromanagement, if you are visualizing the process, in between the reaction dynamics, what happens, you cannot visualize unless the machine should be able to visualize. If that can be captured, you can certainly get your product onto better quality level and better throughput level. Manufacturing execution systems as well as virtual product development. Today we still have a product development as a separate entity, but in the coming days product development is an integrated process done through the overarching intelligence of the machines. Very little of management or very little human influence. Then rapid prototyping as well as manufacturing. It's all part of the programming where we do intelligent devices built into the system. And virtual commissioning. By sitting remotely, you can do every process of commissioning. So that's what the digital system, that's what the digital machines will do. Embedded software, embedded sensors, that is going to lead the machines which in the coming years. Yet there are a lot of elements that needs to be harmonizing. Materials management, supply chain management, skill development, financial systems, human resource management. All of them will be harmonized only you can go into a digital factory. You can't have a digital factory set up in isolation without addressing various real-time harmonization of the various isolated functions in the value chain. Then challenges of real-time harmonization. See, it's an operating state where machines and other assets has to communicate, either directly or through the process of automation and produce intelligent results. And that's a big challenge in real-time harmonization, unless we build up our machine systems to the highest level of intelligence. In a developing country, of course, it's a challenge, but we need to certainly catch up with it. That's where technology upgradations, addressing the technology obsolescence and bringing up technology upgradations coming in. Then there are certain informations which are in between the layers, which is not visible, which we all human resources missing. To capture those informations which are within the layers, especially in the process industry, in a reaction dynamics, between the two temperatures, between the two partial pressures, what happens? To capture that, whereby you can bring down the cost of reaction time to a great level, as well as bring up the reaction equipment's smaller sizes. Visualizing and eliminating that missing link is one of the critical, and over this, you can't really build up all this real harmonization unless the skill, we do a cultural transition to that. Skilling alone is not sufficient. We need to go one step or two steps further to accept those. This is how the world, this is how the data is coming in. It takes a lot of cultural change to come into, from what I call as a chalega mentality to precision level, high precision level. Now, when I go back to the automation, I said this digital and automation has to be integrated. What is the value creation by automation? Very seldom people understand it. Because automation, people will think we lose jobs to people. In a country like India, that's a question which comes, can we afford? But very seldom we forget. The automation really gives us the social equity, enhancement of the capability of the social people. You are not really losing the job, but you enhance the capability of the human resources. So increase the throughput, whereby adoption of the automation reduces the downtime, enhances the capability of the people employed, enhances the capability of the system devices employed. Reduced cost. These are all, I would say, corollary to everything. And improved quality and consistency. If a human interface is required to produce a qualitative, repeatable, reliable information or reliable product, it is a Herculean task, whereas machines can do much better, much faster. Improved accuracy, reliability, reduced human interface. There are processes where you cannot have human interfaces, especially in hazardous area processing. So naturally you need to have automation there. And safety. Today, if you need to export any components, any system to overseas, the first thing is the safety in concern. Unless you have, or is it occupational safety and health certification, you can't really do their exports. This is going to be a process that your factories has to have certification, your process has to have inbuilt systems employing occupational safety and health. Enhanced asset productivity, direct benefit of the employing adoption of automation. Enhanced energy efficiency. If we properly process our systems, if we properly employ, it is said in the country we can have 10,000 megawatts saved just by streamlining, just by harmonizing the processes, just by harmonizing the devices within the system. You can save 10,000 megawatts energy generators. You can imagine how much energy we can save by having adoption of the automation and integrated operations. Controlled emission environments. Couple of years back, any financial institutions clear project cost without looking at what is it being given to the environment. Today, if you need to have $100 million project to be financed from a funding agency, especially from international agencies, you need to build in what is known as cost for green code. Without green code employment, your funding, your financial closure will not come. So adoption of automation into the process will certainly help saving or protecting the environment. Verification, validation and tracking. Without automation, these three V's cannot be done. Verification and validation. And social equity enhancement. As I said earlier, the concept of, or the thought process of that, we are losing the energy, you have to change it to that. The people employed are becoming much more capable to take much more higher responsibilities. Their social equity certainly changes to higher level of thinking process as well as operation process, and that overall gives you importance to the society. And roadmap for modernization for the automation industry. Continuous innovation and technology upgradation. Especially on the automation side, the electronics components life cycle is not more than 5 years. If you do not continuously upgrade, you will be lost somewhere. So you need to have upgradation continuously employed to address the hardware components built into the systems. And innovation is a process because day by day the technology changes. Either the energy efficiency comes into picture, or the environment guidelines becomes much more stringent, or the safety requirements continuously change. All these sustainability factor, if you need to build into the systems, you need to certainly have your component system upgraded to the required level of operations. And this is a process. Even in that process, your certification of the equipments is essentially required, built on that. Set up additional research and development facilities. In country today, we have limited research and development facilities. We need to have additional research and development facilities. Along with that, a lot of certification agencies. Because any automation product, if you develop in the country, Indian market is not sufficient enough to sustain. If you need to sustain the automation product lines, you need to go into global. So you have to adopt automation and go global. If you need to go globally, you need to have certification, global standard certification, global standardization employed and standard certification. So you need to have research and development combined with certification from international agencies built, nourished here and developed here. And recognition to adherence to IPR. Intellectual property rights. Seldom we have really looked at. When we start for development of products, certainly we need to look at what is it that developer has? So the culture has to change, have IPR, respect for IPR, and not necessarily to be enforced, but a self-enforcement, self-understanding is essentially required, that IPR certainly creates a certain amount of value for us. And technical collaboration. It's not necessary that, or it's possible that everything we do develop from scratch. You need to have collaboration from overseas in order to sustain, in order to grow globally. Otherwise, in a global market, if we do everything in India, everything you have to do, it is just not possible to sustain. Joint ventures, if not collaboration, joint ventures. Industry institute partnership. I said this, 1 million students coming out of year college, not more than 10 or 15% really not employable. Earlier, if you look at, there was a concept of visiting professors. From industry used to go to the academy. But today, industries are all Q1, Q2, Q3 concepts. Every quarter the number. So the industry is not able to spare human resources, intelligentsia to the universities. So the curriculum is living behind. Unless we address that, industry institute partnership, train the trainer program to bring it, get professors or lecturers to the industry, train them and they go and train. Or the programs which we, automation industry is doing, like Campus Connect, whereby we address the both curriculum as well as training. Because we have started, it's a process. We have started with 4. Over the coming months, we are wanting to do 40 educational institutions. We may go into 400, 4,000 later. But it's a beginning we have made. So industry institute partnership is a must to address both skill, technology, as well as faculty facilitations. Standardization. That is the biggest challenge for us. If I replace one spindle of one valve today, it will not fit into another valve. How can we do that? So standardization is one of the biggest challenge which we are facing. On the other hand, if you go to Germany, for everything there is a standard. But here, we produce without standards. So standardization is one of the most important. Bureau of Indian Standards, in association with major industries as well as institutes, is taking a lot of steps in bringing standardization, but it is, and we have also adapted certain standards of IEC 61750, but I hope it's still a process. It has to be certainly built into them. Then address technology obsolescence. If you have to live with technologies adopted or employed, maybe 10 years or 20 years, we can certainly not sustain in this coming world where energy is costly, environmental protection is important, safety is a mandated one. Issues in India. See, why automation in India is not caught up with? Because we are a late starter. Even in our day-to-day life, automation has become very, very delayed start. We look at road network. We did not have much of the, even today in the rural areas, we don't have the signal system, no automation. Or if you get into toll plaza, you don't have much of automation. Just because of the automation employed in the toll plaza, you can do much more better. So in our day-to-day life, automation has not been employed over the years. As a result, in India, automation has been a late starter. And at a later date, automation conceived to be a social system by which people are losing jobs. So we need to change that. We need to have automation concept brought in. And bring in small and medium enterprises. Out of the 100 million people employed in small and medium enterprises, nearly 80% is not known to automation. So we need to change that culture. We need to bring them to the automation level. Then most of the Indian projects have evolved with step-by-step mechanism. Automation has come late. As in the last question and answer session said, if an equipment fails, nobody bothers about the cost. But if there's a problem in the automation, everybody look at whether I am getting return on that investment. That has to change. If it is 7 or 10%, it has to be brought in. Automation certainly gives you value. Not only value for today, but for future, sustainability. Quite likely with vital sensors, all these missing information we still have, can get it. And need of the hour is integrate automation into both supply and demand. And then automation planners has to bring in a lot of stage by stage steps to bring in. And couple of them are directly related to production, couple of them are indirectly related to great value, environmental protection. The most important of the is sustainability. And in sustainability, it is people, planet, and profits. If you need to have planet protected, you need to have automation inbuilt into the system. Whether monitoring of air, whether monitoring of air quality, or whether monitoring of the land. And through AA, as I said, we are building a better future through campus connectivity. We have just started our national chapter last 2 weeks back. We are going ahead with campus connectivity, addressing the curriculum, addressing the faculty, addressing the trainer programs. We certainly welcome your suggestions for our improvement. So summary is automate to excel. I would say one step, adopt automation, go global for sustainability. And demand and supply. See, you can sub-delegate a lot of your hard tasks, but the responsibility remains with you. You need to certainly imbibe that automation has to be our day-to-day function in life as well as in our environment to comply with. Thank you.